Hi guys! So I am Engineer Jewel Ryan Nicole Biriosa and I will be presenting to you today about rational expression. So let us proceed to our main objectives or learning objectives for today. So first we have here recognize the difference between rational expressions and a polynomial. So if you haven't watched my video about polynomial, so kindly just browse it on my YouTube channel. And now next we have understand the different operations involving rational expressions. So I will be discussing the tips or suggested steps or methods on how to solve those operations involving rational expressions such as addition, multiplication, subtraction, and then division. And lastly, we have apply the fundamental laws and theories related to algebra in solving mathematical problems. So we will be having several sample examples so that you will be further visualizing what I am talking about or what is the purpose of my tips or steps in real life or real life situation and problem. So again, I will be giving some examples, so hopefully you'll learn a lot for today. It is very important to first define what is our main topic about. So the definition of our rational algebraic expression is it is an algebraic expression that can be written as the ratio of two polynomial expressions. Again, ratio of two polynomial expressions. So, if you also heard about the term rational function, so this is a function whose value is given by a rational expression. So to further visualize it, I will be having or I will be showing you here some examples related to rational expression. So we have here r of x, or our rational expression is given by x squared plus 2x plus 3 divided by or over all over x minus 4. So this expression is obviously the ratio of two polynomials. Why? Because x squared plus 2x plus 3, the numerator is a polynomial. And then x minus 4 is a polynomial also. So we have here the numerator x squared plus 2x plus 3. That is actually a trinomial. And then over x minus 4, which is a binomial. So since this is a ratio of two polynomials, we can say that this expression is an example of a rational expression. So now we have here the second example is 1 all over the quantity of 1 plus 1 over x. Actually, this expression is not in the standard form since we we have here the denominator 1 plus 1 over x, and then 1 over x is one form of a rational expression also, but we can convert this to a standard form of rational expression by multiplying x in the numerator and the denominator. So by multiplying x in the numerator and the denominator, we will be having here this. So by simplifying 1 over 1 plus 1 over x, that is also equal to x over x plus 1. So now we have here a standard form of a rational algebraic expression. So another example we have here, this is just an important note. So we have here a rational expression 1 over x squared minus 5x plus 6. So we must not divide by 0, and hence a rational expression is undefined. So if we divide by 0, the rational expression will be undefined. So if the denominator is 0, for example, here the rational expression again 1 over x squared minus 5x plus 6. And then this can be by factoring this or by getting its factor, we will be having 1 over x minus 2 multiplied by 1 over x minus 3. So, this rational expression is undefined when x is equal to 2 and then x is equal to 3. And then, another important thing to reiterate is any polynomial expression is a rational expression. So for an example, you can think of it as a polynomial divided by the polynomial expression 1. So for example, we have x minus 4 over 1. So any polynomial expression is a rational expression. So I hope that is quite enough for a brief introduction about rational expressions. Now we proceed with the introduction of the basic operations related to rational expression. So we have here addition, subtraction, multiplication, division, and then common factors also. So in understanding fractions and more so appreciating the fact that rational expressions are like fractions also, so I think that main fact that rational expression is also like fractions is the main fact or the main information that you need to know to handle rational expressions properly and successfully, hopefully. So suppose we have here R over S and then T and U. So we have variable RS and then TU, wherein we have rational expressions R divided by S or R over S and then T over U. Again, R, S, T, and U are polynomial expressions, since our definition again of rational expression is it is a fraction or a ratio of two polynomial expressions. Again, we have here R, S, T, and U. R and S is a rational expression, same as with T and U. And please take note that R, S, T, and U are polynomial expressions. So, in understanding these basic operations, kindly note that this includes the special case that the polynomial are constants and the rational expressions are fractions. So with that, these following rules hold, or as you can see in our image here, we have RU over SU. So we can cancel out here U, which is we termed as common factor. So in such a case that you encounter this, your answer will be R over S, since you may omit U. And then in addition, we have R over S plus T over U, that is equal to RU plus ST over SU. And then we have here for subtraction, we just need to change the sign from addition to subtraction. So almost same process with addition and subtraction. You just have to take note of the addition sign and the minus sign. For the multiplication, that is actually, if you watch my video about fractions and decimals, so I discussed there on how to I give emphasis on multiplication and division of fractions. So I think if your foundation about fractions is not that strong, you may refer to my video about fractions, so that it may further help you about this topic. And now we have here for multiplication, so we just need to multiply the numerator and then the denominator. So we have here RT over SU. And then for division, RS divided by TU, we need to reciprocate the divisor, which is tu, to ut, and then multiply it. That is why we have here ru divided by st. So we will be discussing it. I will be giving more details on the upcoming slides. So let's proceed. First thing that we have here is the simplification of rational expressions to lowest term. So this is the one related to the common factors mentioned earlier. So I will be giving you here an example, but before that, please take note that when we mean lowest term, so a rational expression is said to be in lowest term if all common factors of the numerator and the denominator have been cancelled out. So again, a rational expression is said to be in lowest terms if all common factors of the numerator and the denominator have been cancelled out. So we have here an example. X squared plus 8x plus 16 divided by x squared minus 16. So first thing to do is um, my recommendation is to first factor the numerator and then factor the denominator and then do the canceling. So first we have here factor of perfect trinomial square of the numerator. So our numerator is a perfect square trinomial wherein the factor is x plus 4 multiplied by x plus 4. Again, tips on factoring if you want to have further knowledge or more knowledge about factoring, I have a video about polynomials, special product, and factoring. So if you want to watch it, you may watch it. So next we have here, so please don't forget to write the denominator even you are factoring the numerator only. And then we have here to factor the denominator. Factor the denominator. So our denominator is a difference of two squares wherein the factor is x plus 4 multiplied by x minus 4. So we do now the canceling of similar factors. So the similar factor here's the similar factors here is x plus 4. So you may I will just look for a good color. So let's pick blue, good color of highlighter. So we may cancel out x plus 4 here in the numerator and then x plus 4 here in the denominator. Our final answer will be x plus 4 over x minus 4. So that is the lowest term or the simplified version of our example x squared plus 8x plus 16 over x squared minus 16. We proceed now with the multiplication of rational expressions. So I am sharing with you two major steps in how to multiply rational expression. So first, completely factor both the numerators and the denominators of rational expressions. And then, next we have to cancel out all common factors to make the product in lowest term. So this is how to do it. I will be giving you an example. So an example here is quite a very long example. So again, tip is first completely factor the numerator and then the denominator and then cancel out all the common factor. So and then to achieve the product in lowest term. So again, I will just be reminding you how to multiply fractions or rational expressions. Just multiply the numerators and then multiply the denominators. However, there are times na there are so many factors wherein you can cancel out each other. So we have here an example, x cubed plus 8 divided by x squared plus 4x plus 4 multiplied by x squared minus x minus 6 over x squared minus 2x plus 4. and then multiply to x squared minus 2x all over x cubed minus 5x squared plus 6x. So as you can see here, we factor first the numerator and the denominator, wherein here's the factor of x cubed minus 8. Ayan. X plus 2 multiplied by x squared minus 2x plus 4. And then let us focus first on the numerators. And then x squared minus x minus 6 is equal to x plus 2 multiplied by x minus 3. So you must be good in factoring to achieve a proper lowest term of a certain rational expression. And then we have here x squared minus 2x, and then the factor is x times x minus 2. And you, after factoring or extracting the possible factors of the numerator, you proceed with the denominator. So for the x squared plus 4x plus 4, we have x plus 2 multiplied by x plus 2, or x plus 2 squared. And then x squared minus 2x plus 4 is equal to x, yes, this is actually very hard. I mean, there is not really a common factor for x squared minus 2x plus 4. Because I think x minus 2 squared is, if the 2x or the coefficient of x is 4, or I think because negative 2, yes. So, we leave it behind muna since we cannot think of a possible factor of that. So, probably in the solution, it can be cancelled out. So, hopefully. And then, x cubed minus 5x squared plus 6x. So, first you factor out x first, and then you will be arriving at x squared minus 5x plus 6. And then you factor that out, you will be having x minus 3 times x minus 2. And then don't forget the x that you factor out earlier. So then we have here the canceling out of similar factors. So we cancel x plus 2. And then we have here this x plus 2. As you can see here. So this is almost the same. I am just using the second line as the canceling out of everything. And then, as I have said earlier, x squared minus 2x plus 4 was cancelled out. And then we have here x minus 2 and then x minus 2. We have here x minus 3. So as you can see, the details are provided below on the 3rd, 4th, 5th, and 6th line. So I am just showing you that you can shorten the solution by just canceling everything out in after factoring the numerator and the denominator. But this is just quite messy, or you may miss some important variables. So if you think you are not confident enough about canceling out, so I think rewriting and rewriting your solution is a must. So I think everything was canceled out, so that is why our final answer here is 1. So the lowest term of our very, very long example is 1. Now we have here the division of rational expressions and further steps on how to achieve the final answer in lowest term. So I have 4 major steps here. First, reciprocate the divisor. So I mentioned this earlier, but I will be reiterating this because this is worth mentioning again. Next, change the division sign to multiplication sign. So that is upon reciprocating the divisor. And then for the lowest term, or the factoring or simplifying your answers, factor both the numerator and the denominator, of course, of the rational expression. Please take note, completely factor it. And lastly, cancel out the common factors to make the quotient in lowest term. So as an example here, we have 2m plus 4x over 3mx divided by 6m plus 12x over 6m squared. So first thing to do again based on our step is to reciprocate the divisor. So we have here the reciprocal of 6m. So we'll be using blue ink again. So 6m plus 12x over 6m squared is equal to, so the reciprocal of that is 6m squared x over 6m plus 12x. And then upon doing that, change the divide sign or the division sign to the multiplication sign. So, and then proceed to the process of multiplication. And by doing the process of multiplication, kindly factor completely the numerators and the denominator. So we have here the factor of 2m plus 4x, the numerator is 2 multiplied by m plus 2x, and then the factor of 6m squared x, so we cannot factor it, and then 3mx, the denominator, so as it is, and then 6m plus 12x, we can factor out 6, and then the factor is 6 multiplied by m plus 2x. Now that we factor completely the numerators and denominators, we have here, we can cancel out actually m plus 2x. So as you can see, m plus 2x and m, 6. We can cancel out also 6, and then we have here m here and then m here. However, we will be having still 1m since we are dividing m squared over m. So that is equal to m. And then we can cancel out again x here and then x here. So our quotient in lowest term or in simplified form, simplest form is 2m over 3. So I hope that the process of multiplication, division, and the process of simplifying answers in lowest terms is quite clear to you, but in next slide, I will be discussing more about the addition and subtraction. Again, as I have mentioned earlier, so for the addition and subtraction of rational expression, the formula or the process is almost the same, but then you will be utilizing two different signs, of course. For the addition, that is the plus sign, and for the for the subtraction, that is the minus sign. So we have here two major categories for similar denominators and for unlike denominators. So for similar denominator, you just have to copy the denominator and then perform the addition or the subtraction process. And for the unlike denominators, you have to get the least common multiple of those of, for example, B and D, or you others. One suggestion also is others are multiplying the denominator. They are not getting the least common multiple of the fraction, or yes, of the fraction. And then they are just multiplying the denominator and they do the factoring or the canceling out after multiplying it. So you may multiply the denominator, and then to get the value of the numerator, so here's my step. So I will be using here the blue ink again, sky blue ink. So we have here this factor BD. You have to divide it by B. So you have to divide by the denominator and you multiply it on the numerator. So BD divide B is D multiplied by A, that is AD. And then again, for the sign, you use plus for addition and you use negative or minus sign for the subtraction. BD divided by D here for the second rational expression or second fraction. We have here BD divided D is B multiplied by C, that is BC. As an example, we have here 2x squared over x minus 4 minus 3x over x minus 4 plus 2x over x minus 4 minus 2 over x minus 4. So, since all denominators are similar, just add all the numerators directly and retain the denominator. So, that is in accordance with our similar denominator process that I mentioned earlier. So again, if it is unlike denominator, you will be getting the LCD or the least common denominator, to be specific, since we are talking about fractions. So now we solve this problem. So since again we have here similar denominators, we just copy the denominator x minus 4 and then proceed to the process of subtraction or addition. So we have here 2x squared minus 3x plus 2x minus 2. So our answer here is 2x squared minus x minus 2 over x minus 4. So I think there is no other factor for this final answer. So this is our lowest term and our answer for the addition and subtraction of rational expressions. Before we proceed to actually this is our last topic for rational expressions today. So for this content actually. And I will just mention, or I will be highlighting the LCD and LCM. So as you can see, as you can hear earlier, I always keep mentioning about LCM or the least common multiple, and then I mentioned LCD. So LCM, in getting LCM or the least common multiple and the least common denominator, so the process is actually the same. However, the LCD is more specifically about the fractions, or it refers about the denominator. So the right term for LCD is the lowest common denominator. But then me personally, I am used to saying LCD as least common multiple. So I will just be highlighting that LCD is a special case of LCM. However, the process is still the same in getting the least common multiple and the lowest common denominator. So now we proceed with the complex rational expression. So complex rational expression is a rational expression that contains additional rational expression. So again, a rational expression that contains additional rational expression in the numerator, the denominator. So it can be in the numerator, in the denominator, or both the numerator and the denominator. So we can simplify complex rational expressions by writing the numerator and denominator as a single rational expression and then dividing them. So to further visualize it again, I will be giving you an example for that. So we have here 25 minus x squared over y squared. So as you can see in the numerator, we have here a rational expression, which is x squared over y squared. And then in the denominator, we have here 5 minus x over y, wherein x over y is another rational expression. And in general, we have here the entire expression as a rational expression also. So this is what we termed as, or as are an example of a complex rational expression. So first thing to do is make the numerator and denominator as a single rational expression. So how to do that? So first you find their factor, or assume 25 as 25 over 1 and then get their LCD, which is y squared. And then for the denominator, wherein we have another rational expression x over y. So we assume 5, which is 5 over 1 also. And then get the LCD, which is y. And then simplify it. And then once you are done, divide it. So the denominator, the numerator 25y squared minus x squared over y squared, as you can see here, is divided by our denominator, which is 5y minus x over y. And then since we are in the process of division, we get the reciprocal of this divisor. So as you can see, we have here y over 5y minus x, and then proceed to the multiplication process. So once you are in the multiplication process, you may also first think of factoring your numerator and denominator completely so that we can cancel all terms, all possible terms to be canceled, and then arriving at a lowest term or the simplest form of our final answer. So we can cancel out here 5y minus x, and then we can also cancel y here, so y, and then y squared. We have a remaining y here. So our answer is, final answer actually, is 5y plus x over y. So I really hope that you gained a lot for today, and to be honest, I enjoyed making this content because these are the parts that my favorite topics. So if you wish to have a copy of this PowerPoint presentation and a complete module of rational expressions, and I also added in my module about rational expression is I included about linear equations. So that is my next content. So kindly email me at ryannicolo5@gmail.com. Thank you for today.